In this video, I'm going to attempt to teach the fundamentals of calculus in a very short time. So there's three areas of calculus that you want to be familiar with. The first one is limits. Now, limits help you to evaluate a function. Let's say if we want to evaluate f when x is equal to 2, but for some reason the function is undefined or we just can't do it. Well, a limit will allow you to see what happens as x approaches 2. And so limits are very useful to find out what happens to a function as we approach a certain value. Now, the second area of calculus that you want to know is derivatives. So what are derivatives? Well, basically, derivatives are functions that give you the slope of an original function at some value. So let's say if I have some function f of x. The derivative of f of x is known as f prime of x. Now, this function here will tell me the slope of this function at some x value. It will give me the slope of the tangent line. So derivatives are very useful for calculating rates of change. Now, the third area is integration. Integration is basically the opposite of derivatives. With integration, you're basically finding the area under the curve. Integration is very useful for calculating how much something accumulates over time. And what you need to know is that derivatives and integration, they're opposites of each other. For instance, we said that the derivative of the function f of x is equal to f prime of x. So this is the derivative of the original function f. The integral of f prime of x is f of x. So this is the antiderivative, or the integral of f prime. So you can think of integration as finding the antiderivative. Now let's begin our discussion with limits. So let's say that f of x is x squared minus, oh, that is a terrible looking 2. Let me do that again. So let's say it's x squared minus 4 over x minus 2. What is f of 2? Can we evaluate the function at x equals 2? Well, let's find out. So if we plug in 2 squared is 4, 4 minus 4 is 0, and 0 over 0, what is that? Well, we can't figure this thing out, so that's indeterminate. Therefore, we can't evaluate the function at x equals 2. And so this is when limits become important. So if we can't find out the value of the function when x is 2, can we find out what the function will do as x approaches 2? So what happens when x is, let's say, 2.1? So if we were to plug in 2.1 into the function, you should get 4.1. Now, what if we plug in a number that's even closer to 2? Let's say 2.01. Well, if we do that, this will give us 4.01. So notice that as x gets closer and closer to 2, the value of the function gets closer and closer to 4. So thus, we can use a limit expression. So we could say that the limit as x approaches 2 of x squared minus 4 over x minus 2, we know it's equal to 4. But to show your work, what you need to do is factor x squared minus 4. And when you factor it using the difference of squares method, it's x plus 2 times x minus 2. And so we could cancel this factor. And so we're left with the limit as x approaches 2 of x plus 2. So now we can use direct substitution. So we can replace x with 2. So this becomes 2 plus 2. And this gives us the limit, which is 4. So this tells us that as x gets closer and closer to 2, the y value, or f of x, will approach a value of 4. So even though f of 2 does not exist, the limit as x approaches 2 of the function f of x, that exists, and that's equal to 4. And so make sure you understand that limits help you to see what happens to a function